ESF is the oldest, largest, and most distinguished institution in the United States that is focused on the study of natural resources and the environment. Hello and welcome to this edition of Improve Your World with SUNY-ESF. I'm Dave White. Our topic is deconstruction versus demolition. At a casual glance from the sidewalk, it might look like these houses are being demolished, but that's not the case.
The technique that we use is called hybrid deconstruction, and basically what that incorporates is human labor and this machine here. This is the bulk of the equipment that we use, this 10,000-pound all-terrain forklift. And we use that machine for a couple of different reasons. One, it expedites our process. We try to make it a more efficient process so that we can get through a house in this size in 3 or 4 days when we don't have assistance from Diversified and some of the other folks on site. Conventional practice prior to that for deconstruction and salvage of materials, this house would take in upwards of a month, maybe 6 weeks. And the difference is that more conventional practice would have involved stripping the roof by hand, removing each plank by hand, lowering things to the ground, scaffolding this whole house, and you can see how worker safety is compromised because you have people at 25 feet, 30 feet up in the air, and number two, efficiency is compromised. And the name of the game for everybody today is efficiency and cost effectiveness, right? If you're going to save materials, it's got to be cost effective. It can't just happen and because it's the right thing to do, because it's the green thing. I wish that we made decisions based on what was the right thing to do and the green thing to do, as opposed to what is best for the bottom line, but that's not the reality of the situation. I've worked for some of the wealthiest clients in the state. You see their names and faces on billboards, and when it comes down to it, they're not willing to pay any more than somebody that's just going to come in and crunch it up and throw it away. So that proposes a huge challenge to us because it is much more labor intensive. Yes, Dan's machine costs more than this machine, but our labor investment is way, way more. I've got 5 people down there right now ripping apart panels and that kind of thing. Secondly, when we started doing this in 2007, what was really important, we saw this as a vehicle for job training, for young adult training. And the last thing I wanted was workers in uncompromising situations that were on the roof and on scaffolding, on extension ladders. We address that situation by not even having extension ladders on site. You will not find an extension ladder on this site. If you don't have an extension ladder, people can't fall off them. And if you don't have people on roofs, people can't fall off the roof. So what we do is we cut up the house into big panels, big sections, and we lower those sections down to the ground and we rip them apart on the ground. We take the good stuff and then we throw everything else away. Some people might say, you know, the supporters of the conventional that we throw too much away. And you know, they have a valid argument. We throw a lot away. We throw away wall sections, we throw away 2x4s that are in the walls, we throw away some structural elements that may be in porches that are big sandwich 2x10s that are nailed together with a bazillion nails. So, but our theory is, in so doing, by coming in and getting in here in the shortest period of time and maximizing our diversion, and getting the best quality of materials in the shortest period of time, that we're able to get to another house that has good materials, and another house even, before they even finish the first house. And we believe that by doing this, we're going to get more high quality materials out than if we would have stuck on one house and saved every stick. Because a lot of those materials, we'll rip off that gable, and it's all shorts. It's all 2x4s or 2x6s that are 4 feet or 6 feet long. There's not a lot you can do with it. Not a lot you can do with a 2x4 rough sawn piece of lumber anyway that's worth, when the competing price for a 2x4 is $2 at Home Depot. So the question is, do I invest my labor into stripping this wall, this exterior wall apart, taking all the sheathing off and all the cedar clapboard and all the plaster and lath and all the paneling and all of the stuff that's on the inside of there to get, I can count how many 2x4s are in that exterior wall, and there's about 12 full-length 2x4s. The rest are shorts under windows and indoor openings and that kind of thing. So we cut our losses and we say, okay, we're not going to save exterior walls. We'll save interior walls when it's practical, when we have a little extra time. If it's our own job, I always save interior walls. On this job, it's a little bit more challenging because we have the heartbeat of time, you know, and the next contractor breathing down our neck. So it's really about getting in and getting out in the shortest period of time and maximizing what we save. So that's what it's all about.
There are three categories of deconstruction.
Traditionally, what's known as soft skim or soft deconstruction is done where all of the valuable componentry in the building that can be easily accessed, that's the cabinets, it's the architectural millwork. Windows in many cases, especially ornamental windows, things like that, ornamental grills, appliances if they're still available, counters, sinks, some of the plumbing fixtures. All of those are components that one can effectively easily dismount from the building and remove, and there's already an existing resale market for all of that stuff. And so it's fairly simple to take that first step and go through soft skim or soft deconstruction.
In our first wave, we send people in and we pull out all the windows, all the doors, all the cabinets, all the fixtures, everything that we believe is valuable enough. Do we save every door? No. Do we save every window? No. And that's because, you know, the windows, you can see the windows that are still left in this house. There are some sashes, and they're either damaged, decayed, locked into place with too many coats of paint to the point where it's just not feasible to do that. I have an inventory of about 3,000 sashes already, and we restore windows already. But there's a finite demand, and I'm not going to take a junk window when I've got 50 of the same size already.
To go a little bit further, the hybrid model that we've seen here with the ESF project is to go ahead and complete the soft skim and then begin to disassemble the building into panels. And when you get those panels down, then figure out strategically what valuable materials in each of those panels and which of those materials it makes sense to try to go and harvest out of those panels.
The second wave, we come through and we prep this whole house. We make strategic cuts. You can see holes, you can see cuts down the side. We make big cuts in the floor where we're going to eventually hook chains and pull it out, and we remove all the shear walls, the walls that are opposite the length of the house. Because then what we do is when we get down and that roof is off, we grab a hold of that roof, that floor section, and we pull it with the machine, and all the walls collapse. So all of the walls collapse, the walls are junk anyway, and we pick up that panel, lower it to the ground, and rip it apart and get all the 2x8s and 10s and 12s or whatever it is out of there. And all the flooring if we can. There's big panels of flooring here that we've started to sort through and palletize. There's lots of joists all around, lots of flooring. Next week we're going to start getting all these into more meticulous piles, but right now it was about staying ahead of the demolition contractor, staying ahead of the foundation folks, and giving ourselves a little bit of breathing room so we could keep rolling through this project.
A further level of deconstruction would be full deconstruction, in which you look at all of the materials in the building and classify them into their groups. What's wood, what's glass, what's metal, what's masonry, and extract and compile all of those materials individually for further use down the road. So that's really, in terms of depths of deconstruction, everything from soft skim all the way to full deconstruction is sort of the gamut that's out there.
A full-scale deconstruction effort is time-consuming and therefore very expensive. Plus, location has a lot to do with whether it's worth it. Disposal costs have a lot to do with it too. Anywhere in upstate New York, landfill disposal costs are very low.
We have really, really cheap disposal costs. Really, really cheap. And when I say cheap, a lot of contractors are paying, because I'm one of them, $25 a ton at the landfill. So, you know, our competitive advantage in deconstruction is that we don't throw as much away. And we hope to save and offset some of that labor investment by saving at the landfill. Well, I might divert 20 tons of material from this house, but that's not very much money when I'm paying $25 a ton. Okay? I mean, that's $400 or $500. That's barely, you know, somebody at minimum wage for the week, you know? So you don't offset much by doing all this work to get this lumber, which underscores the importance of it being a very time-efficient process. So we have that obstacle, and people will be like, well, why are the landfills so cheap? Well, we have space. You know, we have the luxury of space here. If you go east to Boston, they're paying $150 to $200 a ton. New York City, it's even more. Seattle, $100, $125, and deconstruction becomes a little bit more practical. So one of our assets are the abundant amount of space that we have, and unfortunately we're, you know, building landfills in prime agricultural land, but you know, those are problems we're going to have to deal with in the future. That has made our process much more challenging.
So if you're looking to start a business in this field, one of the big things you have to think about is who is the competition. And the competition is demolition. And the costs of demolition are very directly tied to how much time you spend with big equipment and an operator running it, and then how much money you spend sending that off to the landfill. And what makes the point Mike was making is that we have a huge differential between our urban areas along the, for instance, in the Northeast along the coast and out west along the coast, and then the rest of the country. So tipping fees in those urban areas can easily be 4, 5, 6, 7 times what they would be here. And that's a significant, that's an order of magnitude difference that affects whether or not a business is strictly viable based on the economics alone of it. So yeah, it's really hard when it's almost free to throw things away to make an attractive case for the economics of deconstruction in places like this. Whereas in the Northeast, in Boston, in New York City, places like that where they're paying a lot of money and they really have to ship their waste a long ways, there are very sensible economic reasons to simply not even think about demolishing buildings, but rather go ahead and separate and reuse materials.
In fact, even going the hybrid deconstruction route, as is the case in this project, it's more expensive than just demolishing the buildings.
Generally, the step up to hybrid deconstruction approximately doubles the cost of demolition. So for a single-family home, a demolition cost might be in the neighborhood of $6,000 to $7,000 to $8,000, something like that. And hybrid deconstruction then approximately doubles that cost. The gained materials from that now are really entering what's a nascent market for this type of thing. So there's not a standing market for a lot of these used building materials you harvest in that fashion. So whether or not it's economically viable really depends on what sort of market you can capture for those materials. So there are people who are buying lumber from that. There are people who prize the value of the older, better lumber that was used when those buildings were built. And in those instances, there are companies that will come in and, again, pay you for harvesting certain pieces of lumber out of your building. But in general, the projects like that are taken on by people who really want to think a little differently about what should be done with old buildings rather than simply demolishing them.
The third challenging component to what we're doing, particularly with this old housing stock, is that there's a lot of contamination of materials that we no longer use that prevent recycling at its best rates. There are practices, proven and tried practices, that allow for asphalt shingle recycling, where you can strip off the asphalt shingle, they grind it up, they harvest all of the asphalt material, and they can cut their hot mixes and cold mixes to save anywhere from 15–20% of raw material in that product and save a lot of money. The challenge here is that we have cedar shakes, the original cedar shakes on almost all of these houses, with a couple exceptions, and that is, I've taken down almost 100 houses in Buffalo, and all of them, with one exception, which was a new build in 1978, had its original cedar shakes. Cedar shakes contaminate that asphalt recycling process because you put wood into an asphalt mixture and it retains moisture and it expands and it blows your whole mix. So you have wood contamination. The other is asbestos contamination. And yes, they did test this, and yes, it's purportedly it's all safe, but I will tell you that there's 6 layers of roofing, and the chances of every single layer of roofing getting tested on every single house, like if you get contamination of asbestos and a state inspector comes to your asphalt recycling and they do a test and there's asbestos contamination in there, you're done. Like they'll shut down your whole operation and you'll never do business in New York again. So that makes it really challenging to do things like asphalt recycling. We also have a really active gypsum recycling with drywall in this country now. Most of these houses don't have drywall. They have plaster and lath. Sometimes they have drywall all over the plaster and lath, but to go and pry drywall off the plaster and lath to recycle some drywall, which really doesn't save me much in tipping, they're mostly tipping at the same price as landfill stuff anyway, doesn't make sense. So 25 years from now, or maybe 10 years from now, given how we build houses these days, there'll be less quality materials to reclaim for reuse, but more applications for recycling. And that's because you won't have this contamination that we have with this older housing stock.
Arbutus Lake is a relatively productive lake, and we kind of believe that probably other sources of water going into the lake, other inlets, would be fairly close to this based upon what we've done in some chemical balances. We are using this stream to look at how changes in atmospheric deposition, changes in acid rain, changes in the climate, droughts, different changes in the winter, how this affects the stream's hydrology as well as the chemical responses. There are times, like after a period of drought, you have conditions in the watershed which actually produce acidity, so you can have pulses of acidity which are very deleterious to the biota that occur within the site under certain types of conditions. And we're also looking at the water going out of the lake, so we can also look at how the lake itself affects some of these processes. And we also can link this to some biological changes in the lake, as well as biological changes within the stream and associated terrestrial system, the trees and the soils around the stream.
So what becomes of the material salvaged from these houses? Reused or recycled?
I want to differentiate between reuse and recycling because there is a really important thing, and it's something that even LEED standards don't always explicitly dictate. Reuse means I'm going to take this product from this house and without much modification at all, I'm going to incorporate it into another project. So we had a house basically on this site here 2 weeks ago that had 60 vinyl replacement windows, cabinetry, all that stuff comes out, and it can be basically put right back into use again. Some of that stuff that we took out of these houses gets donated locally to Habitat. Some of it comes back to our store facility in Buffalo. That's reuse. And even the joists here, I'll take the joists out of this house, we'll panelize it, process it, band it, and we could use that lumber as is, which isn't really condoned by the building industry as of yet, which is fine, because that's not the real true value. I have people come in the yard and they want to buy a 2x10, a rough sawn, full dimension 2x10, and it's twice the cost of a Home Depot one, and they're like, well, why is it so much expensive? Because that's what I sell it for remilling, and then it can be turned into furniture, or it's done for exterior siding, or rustic finishes, and all kinds of stuff. At some point, there may be huge demand for and a huge supply of lumber because there's just so many deconstruction contractors, because landfill costs have gone up and we've realized that we're destroying the planet and we have to be more aggressive about it, and now there's a huge glut of this material and we need to be more visionary about how we can use it, and can we use it in structural applications so we're not tearing down trees and forests. When we get there, those are problems we're going to have to deal with. Right now there's a limited amount of structural testing that's been done on this material, and the challenge there is that there's too many variables. There's moisture content, there's age, there's species, there's dimension, and you can see it just becomes this huge complex equation. Grading lumber is very expensive, so right now most of this lumber is used for aesthetics and finishes. Exterior siding, interior flooring, clapboard, all that kind of stuff. And there's a strong market for that because the supply is so low. Recycling is, let's say I have a bunch of busted, broken 2x4s that I can't reuse, that I can put into a dumpster, and I can take that to a facility that'll grind it up and turn it into mulch and make it into something completely different. And that takes energy. So yes, it's better than cutting down trees and creating mulch, but it's still, there's a lot more input that's involved after that. Gypsum's the same way. It gets ground up and it's used in agricultural applications to increase the alkalinity of the soils. Asphalt shingles, there's a lot of grinding and pulverization and machines and all this kind of stuff to get it so to be incorporated into a cold or a hot mix.
Diversified's role on the project is basically a helper to the deconstruction facets of the project. So we are like a second set of eyes and ears to help divert from incinerators and landfills different types of product. I just called my office, been informed we got over 200 tons of hard fill for reuse and recycled already off of this project. We're currently running at about 58 to 63% of diversion of wood, soft materials such as what Mike spoke about earlier, the windows, cabinetries, and so on. So what we do is clean up. After Mike does his deconstruction, we'll come in and pull out of what's remaining what we can, divert that from the landfill, and then the remaining cross-contaminant elements will go to the landfill. So we capture about 15 to 18% in addition to what Mike's capturing. ESF is interested in diversion of a minimum 50%, and we believe we're gonna be able to meet that and exceed that, even though the markets don't have very much use for it. We're finding little pockets, especially with the economy being the way it is, of people who are willing to reuse these elements and or recycle.
We'll have tens of thousands of stems of willow growing on this field, producing biomass year after year. Anywhere that wood is going to be used to generate electricity or heat, or also the process now of making ethanol from cellulosic materials. Wood will be one of those cellulosic materials, and so willow biomass crops will also go into those markets to produce ethanol and also heat and power. And so this just fits into the whole thrust that ESF has and continues to move forward with in terms of developing renewable energy systems.
As for the reusable material, ESF has guaranteed a project for some of it. It will be used in the new academic research building to be built near the deconstruction site.
One of the things that ESF is doing by taking this project on is not only are they helping to develop a market for these materials, and so really the market's not going to be there until we begin to have a consistent flow and we begin to have a better understanding of what those materials are and are available. And so ESF is certainly promoting that by selecting deconstruction for this. But ESF also went beyond that in tasking the designers of the building to look at how to reuse some of the materials. And so the designers are actually having the people who are deconstructing the building set aside a known quantity of wood material that they're planning on reworking, that is milling and finishing, so that that same material can be used in the new building on the site. And when I talk about life cycle analysis and closing the loop, that is really it. If we can figure out ways to quickly connect buildings that are coming apart to potential uses in new construction, we've really taken a big step to making this not something that's really on the edge or out of the ordinary, but something that's very sensible and mainstream.
But as mentioned before, it's going to be a while for full-scale deconstruction to become economically viable.
Full deconstruction is really still today only done when there's a strong interest in the community in trying to develop a workforce or a labor force that can perform these operations. So typically full deconstruction is done when there's some economic support on the side of workforce development. And then the people who are employed are actually learning job skills in the construction industry at the same time that you're harvesting those materials. And those are the typical projects that move forward at the level of full deconstruction.
I've been grappling with these issues for about 7 years because I got a research and development grant through Empire State Development at New York State to actually dig into these problems and issues a little bit deeper to figure out how we can make this work here. And what we came up with is what we do now, which is you get in and you get out, you maximize diversion in the shortest period of time, you do the greatest good with the least amount of labor hours, and then you move on to the next house. So that's our formula, and that's very much our formula on these houses. We'll have this house down, and it's all prepped. So we have a day's worth of prep in this house and salvage with 4 people, but we'll have it leveled by the end of, basically in one day we can level this whole house. And what that means is the roof's gone, the second story is gone, the first floor is gone, and all we have to do is pull the floors like we're doing right now. That was that house right there. You can see the one front wall standing. That was a full house on Friday. We leveled that on Friday. We came back. We're just pulling off the floors. So we're about a day and a half per house from start, which you're going to see us pull this gable off, to finish where it's ready for Dan to come in with his folks, crunch up the debris and take that away for C&D disposal.
But in some cases, there's another way to make the case that deconstruction actually makes economic sense.
The issues that are beyond the strict economics are really many and very closely interwoven with larger societal issues. So all of our Northeast cities have large urban cores that have empty buildings. And the empty buildings are huge issues for the cities for a number of reasons. They're providing them services, that is, they're providing municipal services to those buildings. The vacant buildings end up being centers for crime activity and very difficult to provide police protection for. And the value of the other buildings in the neighborhood is directly affected by buildings when they are vacated or left dilapidated or not being kept up. So when communities look at, for instance, changing regulations to require people to perform deconstruction in certain cases or pushing the industry in that direction, it's not strictly typically about the resource management, the materials management type issues we've been discussing. It's really more about what are we going to do for the whole community in terms of controlling that. So if you have a huge number of unemployed people and you have a large number of empty buildings that all need to be some way or another remediated, removed, many of the communities have been going after funding and providing their own funding for people to use deconstruction for those approaches. So in terms of cost to the community for maintaining empty buildings, that in and of itself is a big economic factor to make cities like Syracuse, Buffalo, Rochester, Albany really look long and hard at how to do things differently.
Plus, people are thinking about how to facilitate more deconstruction, not less. Construction management classes have become sustainable construction management classes, and designers are thinking more long-term.
Across academia and across the thinking of, sort of some of the more forward-thinking members of the industry, there's a big interest in figuring out how to look beyond the immediate use of materials and look toward the long-term and really how to close that loop. That is, where do the materials come from and where are they eventually going to end up? And in that sense, academia on the design side is very interested in design for disassembly or design for deconstruction. That is, how do we make it easy so that when we have a material captured in a building and the building's utility is no longer there, how can we extract it easily, efficiently, and then have it repurposed or reused in another structure? So on the design side, there's a lot of interest. On the construction side, there's a similar amount of interest in figuring out how do we no longer harvest virgin materials and how do we reduce the amount of materials that are maybe not even contaminated but just no longer useful for us and ending up being disposed of in places like landfills. How can we begin to close that cycle? So many of the green building standards like LEED and others, have been looking at how to really push the industry beyond just thinking about, well, maybe some wood can be chipped or recycled, and beginning to close those material loops and thinking about a real cradle-to-cradle approach.
That's it for this edition of Improve Your World with SUNY-ESF. Thanks for joining us. We hope to see you again next time.